Good morning, students. Today we are going to learn about refraction of light. In this chapter, we have to study about refraction of light, refractive index, laws of refraction, and dispersion of light. So, we'll first study about refraction of light. What is refraction of light? The light changes its direction when going from one transparent medium to another transparent medium. This is called the refraction of light. Light changes its direction when going from one transparent medium to another transparent medium. This is called the refraction. In this diagram, you will see about a refraction process which occurs in glass slab. The refraction of light passing through a glass slab. We see here in this blue ray shows us a straight direction of light when there is no obstacle in their path. But if you keep this glass slab within their path, this ray changes their direction here, and instead of going straight, it changes their path here because of there are two mediums here. Air is a transparent medium, and here a glass, another transparent medium. And this light ray, when passes from one transparent medium, that is from air, to another transparent medium, that is glass, it changes their path like this. That's why here a refraction of light occurs. Also, you will see here also there is a changes direction. This ray changes their direction here also. That means from air to glass slab, when rays goes from air to glass slab, there is a refraction, and here from glass to air, there is another refraction. Then laws of refractions. If you see the diagram here, this is incident ray and this red ray is refractive ray. The first law of refraction is incident ray and refracted ray at the point of incident N are on the opposite side of the normal to surface of the slab. That point, that is CD, and the three incidence ray, refracted ray and normal are in the same plane. So in first point of this law, the incident ray is opposite to the refracted ray. If you see, this is a normal, and this side of the normal is incident ray and this side is refracted ray. Means incident ray and refracted ray are opposite to the normal surface. And in second point, the three objects, that is incident ray, refracted ray and normal, are in the same plane. This is the second point. Then second law of refraction is, for a given pair of media, Here air and glass, if you take into consideration, air and glass is a pair of media. For given pair of media, the ratio of sin I and sin R is constant. Sin I means angle of incident and sin R means angle of refraction. For the given pair of media, ratio of sin I and sin R is constant. Here R is the angle of incident and R is the angle of refraction. So these are the laws of refraction. Then we will see about a refractive index. The ratio of sin I and sin R is constant and it is denoted by n, small n. N is called the refractive index of the second medium with respect to the first medium. This second law is also called as Snell's law. A ray incident along the normal, that is I equal to 0, goes forwarded in the same direction, is R equal to 0. You see this light ray going from medium 1 to medium 2, means from air to glass slab. Vacuum are given in the table. Different vacuums are shown in your textbooks. The refractive index of the medium with respect to vacuum is called its absolute refractive index. The refractive index of different medium is different, but most of the refractive index we consider in respect to the vacuum, and that is called as absolute refractive index. Refractive index depends on the velocity of the light in the medium. That's why refractive index of second medium in respect to first medium is equal to velocity of light in medium 1 upon velocity of light in medium 2. Then we will see about refraction of light in different medium. When a light ray passes from a rarer medium to denser, it bends towards the normal. When light ray passes from a rarer medium to a denser medium, it bends towards the normal. You will see in this diagram. In second case, when a light ray passes from a denser medium to rarer medium, it bends away from the normal. See here in this diagram, when a light ray passes from denser medium to a rarer medium, it bends away from the normal. And in third case, when a light ray is incident normally at the boundary between two media, it does not changes its direction and hence does not get refracted. You see here that ray goes directly straight when rarer medium and denser mediums are normally at boundary between two media. It does not changes its direction and hence does not get refracted. Then what is mirage? You see, if you see here this diagram, you will get the idea about mirage. These are a plant or tree. The rays comes from that plant, that is from hot air to cold air. So the light rays coming from a distant object appears to be coming from the image of the object inside the ground, as shown in this diagram. This is called a mirage. Twinkling of a star also phenomena. due to this refraction of light. Effect of atmospheric conditions on refraction of light can be seen in the twinkling of the stars. Then we will see about effect of atmospheric refraction. In this diagram, the real position and the apparent position of the sun. We will see in this diagram the atmospheric layers affects the position of the this object or sun. When we see that object, that rays which are comes from that objects which passes through different atmospheric layer, and because of that there is a refraction of light, and that causes the position of the real object. Apparent position of the star also is the example of this refraction. Here increasing the refractive index. Let's see. Then dispersion of light. What is dispersion of light? The process of separation of light into its component colors while passing through a medium is called the dispersion of light. We'll see that phenomena of dispersion in this diagram. This is a glass prism, and when we passes the sunlight through this glass prism, that light is converted into 7 colors, different colors with wire, and this is a dispersion of light. Here a process that separates the light into their component colors. Light is made up of 7 colors. Those are component colors, and those components color will get when there is a dispersion of light. Then partial and total internal reflection. When light enters a rarer medium from a denser medium, it gets partially reflected. That is, part of the light gets reflected and comes back into the denser medium as per laws of reflection. This is called the partial reflection. The rest of the light gets reflected and goes into the rarer medium. You see the refracted rays partially and total internal reflection also in this diagram. Then rainbow formation of production. Here you will see in this diagram the light ray which passes through this water drop, and after passing, while passing this light ray into the droplet, there is a refraction and also a reflection occurs here. A rainbow is the beautiful natural phenomenon. It is the combined effect of a number of natural processes. It is the combined effect of dispersion, refraction, and total internal reflection of light. It can be seen mainly after a rainfall. Small droplets of water acts as a that prism. So, dear students, we already learned about different processes or phenomenon which is related to the refraction of light in this chapter. Now you read the lesson which is in textbooks and solve the exercise. and if you have any doubts, you can call me on this number, and also you can ask the questions on WhatsApp. Thank you.